Hello, my name is Maverick Jackovitz, and I'm going to be submitting the Transport 2 Homework 4. Just to quickly go over our code to start with, and then we'll get into recording it. We have the import functions, and we're just importing it as NP, and just miscellaneous functions. We have the SIPI optimize, and then we're going to be using import of minimize, and that'll be a function we'll use later to reduce some square error. And here are our initial variables from the problem here. So C1, C2, C3, we also have A, B, C, and D, and that's going to be all present in order to save time. Down here is the equation that is present in the problem, our Nusselt number. And then over here we have the randomizing of the Reynolds and Prindle number. So the first one, RNG, to that's function, we have the np.random state, and the number in there is just going to be some random seed, and essentially is going to be used as a way to compare answers. So if I were to run this code on another machine with that random seed, it would come up with the same variables, same answers time and time again. And it's going to be our 50 due to us wanting to have 50 sets of these numbers. And then the Reynolds and Prindle number here, we have the RNG choice, and then we have the NP log space from -4 to 10, and then -1 to 4, which will just be the log from -4 to 10 in the case of the Reynolds number, and then in the case of the Prindle number, we have the -1 to the 4. And that's what we have for that one. Okay, so next what we're going to be doing is adding some noise to our data, essentially giving us the random data points and stuff like that we can compare. I'm going to attempt to write this one-handed. And then in this case, we're going to be using the numbers of 1, 0.02, and then our total that we have, the size, is going to be 50 due to us having 50 numbers, and that is going to come from these values down here. So again, normally distributed across the number of average of 1, standard deviation of 0.02, and then have a constant relative error of that 2% in the collected data. Our vguess set up as that whole hodgepodge of information. Okay, next we're going to have this vguess set up as this equation line right here, just to quickly have that all set up. Next we're going to do our res, and that's going to equal to minimize our equation up here, some square error, and then we're going to do that based off of our variable guess, or vguess as we did it. Okay, and then right here, that equation is going to constantly update based on the previous entry. So it's going to try to get that variable function down to a minimum. And you'd want to do it like this rather than something like polyfit, due to polyfit not taking account the different, the different errors at the end of the lines. And so this one is a much better way of finding out how to get the best line. Okay, so finally, after we have the variable guess compared to the minimize function with our random data, what we're going to do is print our res.x, as well as print our equation, or our variable v that we have up here. Ooh. copy the selection, paste it, and we're going to do a runtime all. And then when it prints down here, what's going to happen is we're going to see that each of our variables that we originally had in the terms of C1, C2, C3, A, B, C, and D, they've been maximized to the best of their possibility with our random data. And so we have the 0.59 repeating with 0.6, 0.386, 0.387, and so our data is very close. And next we're going to try to graph it.